Hi friends, welcome again. So today we are going to learn more about the hybrid electric vehicles. So I hope you have gone through the last video, first video, and I hope you everyone got the information, everyone understood everything, and just we will briefly revise what we have seen yesterday. So, firstly, it was what the introduction about what is hybrid electric vehicle, what we know eh, about the hybrid electric vehicle. Basically, hybrid electric vehicle is having the all the structures as the electric vehicle, but it is having alternate power unit, that is APU. So as an alternate power unit, we are using here mostly the IC engine or CI engine for alternate power source. So that's why it is called as the hybrid electric vehicle, because we are using not only the electrical power, but also we are using the other power, that means by some gasoline engines or any other. So we have seen there are two types of basically there are two types of electric or hybrid electric vehicles. uh, in that we have seen the parallel hybrids and series hybrids, right? So we have seen the difference in between them, and afterwards uh, we have seen the main components of electric hybrid electric vehicle, and even we have seen the structure of hybrid electric vehicle. So now we are going to study today the main and very much important part or component of the hybrid electric vehicle, and that is what? The fuel cell, without which we cannot move the vehicle, and we cannot call it as a electric vehicle, or it will not be run on the electric power. So we are moving towards the next, that is what we can call it as the hybrid electric vehicle or the fuel cells. Okay, so we know that fuel cell hybrid vehicles. So what do you mean by fuel cell? So this fuel cell word, it is showing us it is a power source, and it is having some of the energy. Okay, so as we can see in this oval or this highlighted portion, there are some fuel cells or fuel cell systems that has been arranged in the box to have a power source for the hybrid electric vehicle, or we can say we have some another arrangement also. Here we have the hydrogen tanks, we have the full cell slack, even we are having the powertrain radiator electric motor, then we are having the fuel cell radiator, we are having the power control unit, and even engine also we are having in this hybrid electric vehicle. So now we will see some of the interesting facts about the hybrid electric vehicle in terms of the fuel cells, right? So electric vehicles, always we keep it with the fuel cells, and use the hydrogen uh, as a fuel and power the vehicle, the electric battery when it is depleted. Whenever the power of the electric battery is goes down, then we are prone, or we can use hydrogen as a fuel instead of petrol or the gasolines or anything that may be LPG or that may be CNG, that may be petrol or diesel also. Okay, so instead of that, hydrogen is also one of the means major power source we can use. Okay, so this is what our 21st century, and we have the auto fuel will be replaced by the regenerative resources. Means we are not wasting any amount of energy. A small amount of energy also we are utilizing in this era, right? So this is called as the 21st century, what I can call it as. So everywhere we are utilizing and minimizing the efforts, right? And the power system with the traditional or internal combustion engines, we are replacing it with the hybrid system. Okay, so we are going to replace them with the hybrid system, and finally we will replace by the fuel cell system, and to realize the multi resources. We are not staying up to only with the gasoline engine or only the fuel cell. We are having the multi resources, and that itself making it as a hybrid vehicle, right? So electric driving and zero emission also is there. Okay, so for the fuel cell, we have the many hybrid buses developed. Then we have the high pressure PEMFC, right? And high power NIMH battery, and uh, the hydraulic packs, it's hybrid systems. Oh, I mean, so if you can see here, the higher fuel efficiency, and it is having the frequent charging methodology. Then we can have the active control to the fuel cell, as well as we have the driver's pedal and the surplus peak power for NIMH battery pack that is passively used. Simply we can say uh, we are giving the advantages, so we are giving the plus points of using hydrogen as a fuel, as a third power source. Okay, so simply we can say the fuel cell is what it is, the storage methodology of a power in the form of electricity. Okay, so generate we can have the generated electricity through an electrochemical reactions. So through this we can generate the electricity, and combining the hydrogen with ambient air. Okay, so in this type of fuel cells we are using the hydrogen as a uh, source, and it is making some kind of chemical reactions to generate, or you can say the electricity simply. Okay, so if we have the pure hydrogen with us, and we combine it with other gases. Okay, so if we can say pure hydrogen or any fossil fuel reduces or produces is used as a hydrogen rich gas. Okay, and after the reaction we know that the electricity is generated, as well as the hydrogen will combines with the oxygen, and water vapor will be emitted from that one. So we have here the intake here, and here we are having the fuel, hydrogen fuel. Here anode and cathode we have used here with, and with the help of the reaction, so here proton exchange membrane is given over here. so which is the responsible factor for generating the electricity inside. And we can say it is from electric motor, it is given from the electric motor, and the electricity is given to the electric motor, and the water vapors are going out from this reaction. Okay, so really don't be confused, it is simple thing we can have. So there are different types of batteries we having. Just now we have seen there is a nickel metal hybrid batteries, right? And this lithium ion, we know every day we using this lithium ion batteries. So we can categorize these two fuel cells or batteries, and we can compare them with some sort of categories like current uses, life batteries, okay, life cycles, current contributions, and challenges, and some points that we can use to compare these two batteries, right? So two batteries we are going to compare over here, that is nickel metal hybrid and lithium ion batteries, right? So currently so the first one we are using here, current uses. So computer and medical equipments, these nickel metal hybrid batteries are mostly used, and uh, they worked in the computers, and they are seen in mostly medical equipments also. And the dry batteries, that is light lithium ion batteries, that we use in our cell phones and our laptops, that are dry batteries we can say. And uh, as per as the life of these two batteries, we if we compare, obviously the nickel metal hybrid uh, batteries will have much larger uh, life than the lithium ion, because it is one time use batteries. This can be uh, reusable, even if they get unfunctional, we can make it functional by using some sort of uh, activities on it, or some sort of operations on it. So we can see that the current contribution. Okay, so currently most of the hybrid electric vehicle uses the nickel metal hybrid batteries. Okay, and it has been successfully used in some of the means many of the electric vehicles, hybrid electric vehicles. And we can see it is low in production, but eventually they are functional and having good qualities. But the lithium ion batteries cannot work for these hybrid electric vehicles. So there are some challenges with the nickel metal hybrids as well as lithium ion batteries, right? So firstly we can see uh, obviously they are having good performances. The nickel metal hydride, so they have higher cost and high self discharge rate. Means even if you are not using these batteries, they get discharge because of some environmental issues, or that is its property we can say. And again we can see there is another challenge, that it get uh, heated very frequently. So the heating problem with the nickel metal hybrid is frequently comes across with the vehicle. And if we are using in the vehicle, it is sometimes very much risky if the heating issue is there. Okay, we need to counter that, all these things. Okay, so next one is what? Control losses of hydrogen. As we know that hydrogen is highly explosive component or gas, we can say. That's why we are not using that gas everywhere, but it is highly efficient power source also. But if we loses the control over the hydrogen, that it is very much explosive and dangerous for our lives, and also have a low cell efficiency. It is also one of the challenge we can have. But in case of lithium ion, there are different type of challenges, because they're not that much high cost. They are much cheaper than this nickel metal hybrids. And means here we can have the problem or challenges we can face with the lithium ion is life cycle. It doesn't have that much higher range of lives. Okay, again we can say the cell and battery safeties, right? So it is also one of the issue we can counter here, because sometimes explosion may also occur with the overcharging of this lithium ion batteries. We might have seen in news that many of the mobiles burst because of the bursting of the uh, these batteries. Again we can see it has acceptable cost. We don't have problem of the cost with this. It is, they are cheaper than the nickel metal hydrides. So again there are some more points we need to discuss for the comparison of these two. First one is reasonable specific energy and the power. It is providing us the higher amount of power in minimum resources. Okay, and components are recyclable, right? Because as already I have told you, if even if it get unfunctional, it can be recyclable. Everything will be recyclable by some process. It can come to again in the working condition. Okay, but lithium ion batteries have not that type of ability. Once it get unfunctional, we cannot recover it. So it has high specific energy and power, right, and high energy efficiency also. Okay, and it has a good high temperature performance, because even if it gets heated, it is giving you a good performance, right? And even we have low discharge recyclable parts. So as per as these two batteries is concerned, we are mostly comfortable with the nickel metal hydride batteries, because these are recyclable, rechargeable, having high efficiency, can generate the greater power. That's why we're using it in the hybrid electric vehicles. Okay, so there are some components of motors already we have seen, but there are some kind of things we need to understand, we need to keep in mind. Okay, so electric energy storage system, already we have seen what are the electric energy storage system are there, that are batteries. None of other things are used nowadays. So first one is what? The selecting criteria for the electric energy storage system. First one is desirable attributes. What should be available in the energy or electric energy storage system? First one is what? high peak and pulse specific power. High peak and pulse specific power. We have this thing. We should have this thing with the electric storage system. Then high specific energy at pulse power, right? This also will should be there. High specific energy means we can see that even high peak and pulse specific power. So whenever the vehicle is going to run at the slanted heights, or it is going to up to the slope or down to the slope, so at that time specific peak power should be needed over there when the vehicle is going up to the slanted height, or up to the what we can say slant, okay, or slope. Then it need high specific power, and at that position the vehicle should not stuck over there. It should sustain that high torque. It should provide the needed power over there, right? So these are the some specific desirable attributes we need to have. Then high charge to maximize the regenerative braking. So for the regenerative braking, as itself we have seen what is required, that is when we are going to have a uh, regenerative braking, okay, so it need a very high charge to maximize the regenerative braking system, okay, and also it should have long life, because when we are going outside batting the electric vehicle, then they should not have any problem in the vehicle, in the battery, so that our journey should be very smooth, right? So there are some challenges we will face while selecting the energy storage system. Accurate techniques to determine the battery stage of charge is difficult to get. It is also difficult to develop the abuse tolerant batteries. Okay, then recyclability is also one of the issue with the electric storage systems. Some of the batteries will have the greater ability for recycling. Then we can see there are some of the points we need to consider inside the configuration, or regarding the configuration we are using for the hybrid electric vehicles. Yesterday itself we have seen what is meant by series configuration and what is meant by parallel configuration. Just we should have a look over this. So if we can see the propulsion comparisons regarding the propulsion of the vehicle, we are going to uh, differentiate this two. So series configuration will have both engine and the electric power unit, those both are working and giving the power to the final drive, okay. So engine never means never ever being idle and having the reducing emissions. This is one of the greatest challenge we're having with the series configuration, because every time whenever we are going to run the vehicle, the engine should be run in the series configuration, right? That is the requirement. But when we come to the parallel configuration, we are having optional things. Whenever there is a power loss of batteries, we will turn on the engine, and charge the batteries, and then again shut down the engine, and we can directly tow the vehicle or run the vehicle on the electric batteries only. Okay, so that is the difference between these two. In series configurations, engine drives the generator to run at optimum performances, right? So engine is continuously driving itself to generate um, or generator to run the uh, to run at the optimum powers or optimum performances. Okay, so in parallel configuration, you don't need to separate the generator because the motor generates the battery, because motor is generating the battery, right? Because whenever we are having the um, requirement of the power, we directly start the engine and get the power from it and store it into the batteries, and whenever we need it to run the vehicle, then we are going to run it on purely electric basis, right? So the series configuration allows us to variety of options in mounting the engine. Okay, because here we are having the options to put the engine positions, uh, and there will be a flexibility in mounting the engine, but in case of parallel configuration we don't have that. Okay, so in series configuration is having some it don't need the transmission, but in parallel configuration we need the power to be coupled with the road, or to have the more efficient system, right? So to get more efficiency, more efficient work, we need to have the transmissions over here, right? Simply these are the points I wanted to add in that one. So let us turn toward the fuel cell hybrid powertrain structure. So how we are going to uh, assemble these things, how we are going to do the hybrid powered uh, transmission. So we can see that fuel cell hybrid power train structure uh, here in this block. So fuel cell in the indirect power system is there. Okay, FCIPs, and FCE is connected with ESS in parallel. After we can convert DC or DC to AC converter, right? And we are having the better for the optimization and control of the FCE, and it is an economic selection of the fuel cell vehicles, right? So fuel cell hybrid powertrain structure we have already seen. Just now we can see here there is a motor which is converting the power either in AC or DC voltage, and we are having the engine control system, and here we are having the FC which is controlling the power, and it can have the control unit. Simply we can say uh, the power is going from this to this, and the fuel cell is giving back the power to the motor for driving purpose, right? Here some points we can see: fuel cell direct power system. The previous was hybrid powertrain structure, but here we are giving the direct power to the from the fuel cell to the drivetrains, right? So FC is output is directly taken as a DC or AC, and the ESS is connected with the FCE's output in parallel after bidirectional AC and DC, right? Let me again explain. So these are the things we need to focus on. So there are some terms we are using over here: AC, DC, alternating current, direct current. So we can see here the FCE and ESS. These are the two things are very much important over here. While getting the relation between these two, right? So sorry, voice was not clear, I think. So FCE output power, it is directly converted into AC or DC, FCE. Okay, and FCE must have the good dynamic response to output through the power, and it quickly meets the vehicle driving, right? And if simply we can say that the FC and ESS are very much important. There are, this is what your motor, and it is converted into AC and AC. So whenever it is generating the electricity, it is converted into DC and stored into the fuel cell, right? And whenever it requires to draw out the power, it is taking it as a AC power supply. Okay, so wherever we can see the performance requirement for the vehicle, we need to maintain the voltage for the performances, and we can avoid the large voltage drop, so that it's needed to be done, because if the voltage drops, the performance of the fuel cell and the vehicle, that will also drop down very abruptly. So the FC must be over large to avoid the possible damage. Okay, so this may have the damage also. That's why we need to take care of this. So fuel cell active control system, uh, this is what the electrical part, as we can see. Just for the overview, we need to see this all these things, right? So main controller is there. Okay, so we don't go into the deep or the terms here you're using, just we need to see here it is the driver, what actually happening in the electric vehicle, that we need to understand over here, right? So traction motor is here, driver is here, driver is giving some of the instructions to the control system. Okay, so it is operating the pedal, and as the pedal is operated, the mechanical energy is converted into some form of in codable format that may be read by the main controller. So controller is lookup table. So controller is looking whatever the instruction has been given from this pedal in the form of current IT, and it is converting the signal, right, and processing here with the SOC logic. Okay, so here there it is taking some of the decisions. Okay, so if it is accelerating, then it is giving some of the feedback to over here, and it is giving to the PI. Okay, so even we are having here the direct positive response. Okay, then it is having SOC logic also, it can be developed. Okay, then we can see this is the block where we are going to take the uh, voltage and convert the AC to DC. Gate devices are there, and this there are many electric terms we cannot go within. And see here we are having the motor, traction motor, and it is giving through the proportional inverter is there. There is battery pack, BMS system is there. Then we are having FCE and fuel cell controller is also there. So all these things are controlling how much uh, current should be provided to the motor, how much voltage should be provided to motor, and what are the decisions uh, the driver is taking, what are the instructions driver is taking. The decision maker is what? The main controller. So simply we don't have to see the inside part, we need to see the driver is giving some instructions through the pedal, and it is looking up the instructions in the form of coding language, and it is getting executed and taking the power from the power battery pack and giving to the propulsions or traction motors, right? So as a active control system, the fuel cell controllers receive the pedal signals, right, as already we have discussed from the driver, with the values of pedal speed, driving power required, and that is calculated, okay, by lookup table of motor performance, as we can see here lookup table. So whatever the acceleration speed and whatever the instruction is giving, it has been checked over here in the lookup table, right? And then the target power of fuel cell engine is some of the, sorry, we can say the target power of fuel cell engine is the sum of all the driving power and the SOC regulated power of the battery pack, right? So whenever we are using the term as a power pack, it includes all the required power, or it is the sum of all the required power what you can have, right? And it will be regulated through the control units, right? Through the battery pack. The target current of the DC to DC converter is real time calculated, because what happens, as the vehicle is moving, the feedback should be real time feedback. It should be a real time feedback to have the control over the vehicle. Okay, so it is calculated by the target driving power divided by the bus voltage, right? So whatever the bus voltage is there, means not a bus, st bus, right? There are some bus criterias, that these are the electrical terms. So bus voltage is there, that should be calculated, and the air compressors speed control is based on the target power of fuel cell engine. So everything is calculated, and everything is controlled with the help of control unit, and it is taking some decisions where should be given the power, whether uh, the power is available with us or not, and what bus voltage should be there, and how much power is divided for which activities, that all these things we need to understand. So for example, we can see some of the vehicles, that is Toyota Prius and Honda Insights. So these are the two vehicles we have taken in consideration. So for electric motor generator or power source storage, we are having the output as a 273.6 voltage, that is, it is having 228 cells at 1.2 volt, right? So when we can get it multiplied, then we can have the required amount of voltage. So here in Honda Insight, it is using 120 cells at 1.2 voltage, and giving the output as a 144 volt. So if we, and they are using the same battery type, that is nickel metal hydride, as already we have seen that this is only the best suitable battery we can use for the hybrid electric vehicle. Then power output, we can see this is 33 kilowatt at 5600 rpm, that is enormous power it is developing. It is around 45 hp, and at other place, the Hyundai Insight is providing us 10 kilowatt power at 3000 rpm, right? So as we can call it as the transmission and mileage, this Toyota is giving us the 452, 45, and Honda is giving 61, 68. So as gasoline engine is there, it is having the 70 hp power, but it is giving us output as 45 hp. Okay, and it is at 4500 rpm, and Hyundai Insight engine is having 67 hp at 5700 rpm, right? So emission rating, that we don't have any issue with that one. So there are some strategies we need to keep in mind for the system control. So in order to have a proper determination of the target power of fuel cell, and the same time we need to realize the active control of fuel cell engine, it becomes very important to design the suitable and a reasonable system control strategy. Like, so we can have these two types of categories, control strategies: conventional fuel cell output power oriented strategies, and second one is what means conventional fuel cell output power oriented control strategy. Hence here we are having the output power, or we are having the main source of power is fuel cell. And in conventional control strategy, we are having the where we don't have the real time feedback over there. Okay, but setting the FC as a main power source and controlling the FC's output to follow the vehicle's driving power requirement. If we need a 45 HP power to drive one vehicle, we need to generate that amount of power with the available power source. The FC is working on nearly for all the driving time except for the first cold start, right? At the first cold start, the FC is not that much taking that much of environment, but after that, small driving power requirement, whenever we need, we are having the battery pack at a high SOC, source of control. So generally we see some of the problems in the hybrid electric vehicle. So to transport and storage hydrogen fuel in the vehicle, this that is the biggest risk we are having for storage of hydrogen fuel in the vehicle. That is one of the problem we are having. The cost of producing a powerful fuel cell is high. That is one of the second problem, because producing a fuel cell having very high power and means to run the vehicle, it need very much high cost, as the components of fuel cell are very costly, and we need to buy it from other countries, most of the component. That's why they are having high costly. The size and weight issue, as fuel cell powerful enough to power the car or truck are still rather bulky and heavy. Absolutely, because whenever we are having this type of heavy equipments, and obviously the heavy power source is required to run the this type of high power vehicles or heavy vehicles. Okay, so the bulky structure needed, or bulky source of power also needed over there. Even the research is going on to reduce the weight of the all systems, and just increase increasing the efficiency of these fuel cells, and the technology is also getting matured day by day, and the fuel cells may um, perform well and prove themselves itself to be a viable option in future, or in automobile industry, automobile technology in the upcoming future. So there are some tips we need to keep in mind. uh, if we use the slower speed for driving, it will give good mileage. And if these are just tips everywhere, we will get to have a greater efficiency, maintaining the constant speed and avoiding the abrupt stop, and generally we mm, need to drive in such a way that there should not be the requirement of continuous application of brake, so it will give good efficiency in terms of power. So there are much more advantages of hybrid electric vehicle. So first one is use the less oil than IC engine. So IC engine takes only IC engine if we are using for driving the vehicle. It needs much amount of oil or much amount of fuel to run the vehicle solely on the um, gasolines or any other fuels. So as we not using or we are minimizing the use of fuel, so less CO2 will be released in the environment, and we are just protecting the environment with the use of this type of hybrid electric vehicle. Then fuel efficiency increased, it increases because of we are using the hybrid or combination of these two fuels as well as the electricity. Sorry. So we required less overall mass as we are uh, decreasing the power requirement with the engine. That's why engine weight is also decreased, as well as um, other engine accessories that also get reduced over here with the because of the hybrid electric vehicle. Electric in power sources involvement is taking not bulky load. So if we are having the regenerative braking, it is again producing some of the power or returning the power, and it is giving the high performance while for start stopping the vehicle also. And the battery level efficiency also we can get if we use these tips, that is the slow driving, maintaining the constant speed, and avoiding the abrupt stops. Then even we can get the tax incentives. Okay, so now we can conclude our lecture, these two lectures, with some of the comments, right? So if we go for the hybridization of the cars, or we can integrate the electric system in the upcoming or whatever available cars, it will give us definitely the better efficiency and also saves a lot of fuel today we are consuming, and we can um, just give to the future world. As we know that whatever we save, it is equal to whatever we earn. Okay, so hybrid system gives us the solution to the all problems whatever we have discussed already, right? The problem means what we can say, the emission problems, the environmental pollution problems, low efficiency problems, and limited availability of the fuel. That is also one of the problem. If proper research and development is done in this field, right now it is uh, the most attentive area of researchers. Many of the researchers are doing research in the batteries and electric vehicles. That's why in upcoming days it will get a very good platform, very good solutions for the electric vehicles, and it may promise a vehicle from practical, efficient, and low pollution in upcoming era, right? So we can surely conclude from all this discussion with all these concepts, the similar ones to follow with the, we can say that the similar things we can follow with the better efficiency and conservation rate. They may be our future, right? And we can give something to our future generation. Okay, that's it for today, for this lecture. So just we need to revise this all things, whatever the fuel cells are there. We have totally come across with the fuel cell, and we have seen overall a good uh, knowledge. We have gained the knowledge on fuel cells, as well as much of the things we have discussed. We don't have to discuss again, but we need to keep in mind that whatever the things we are going to study, that are not fully developed till, that are not we can say the up to the mark, that are not fully means what you can say checked by all these practical manner. Okay, so the research is going on this hybrid electric vehicle, but still at this stage we are saving some amount of fuel. That is the big thing we have achieved up till now. So in upcoming lectures we will see much of the other things related to hybrid electric vehicle, and we will again come to know what are the different available resources or energy sources, development of electric vehicle technologies, then battery charger topologies, the charging stations, infrastructures. Then we will see the electric pure electric vehicles. What are the electric vehicles and basic concept and utility for the electric vehicles? Much of the concept we are going to see, even general issues in design of and modeling of electric vehicles. What are the challenges are there? There's also we can see characteristics of batteries also we are going to see, and types of electric vehicle batteries used in the electric vehicles, that also we are going to see. Okay, so let's stop over here, do all these exercises which are given, and just do research by your own also. Use Google for more research, more searching, more detailed information. If you need, you can ask to me as well, and you can use Google, right? So thank you very much for the attention, and if you have any doubt, or if you don't get anything any point, then you can ask the questions. Thank you, thanks a lot. So we will come to with the new lecture. Thanks a lot.